In February 2004, the International Maritime Organization, or IMO, which is part of the United Nations, adopted the International Convention for the Control and Management of Ships' Ballast Water and Sediments, which prohibits the transfer of marine organisms in ballast water. Ballast water is seawater which is uptaken by ships as weight in place of cargo. When a ship has unloaded its cargo, such as raw materials, and leaves port in an empty condition, it fills its ballast tanks with ballast water. Then, when the ship takes on cargo at a port in another country, it discharges the ballast water. The problem is that marine organisms in the ballast water are discharged into different waters as alien species. This can cause destruction of the local ecosystem. For this reason, the IMO established the strict D2 standard for ballast water treatment. Under the D2 standard, ships must purify their ballast water to a level that would allow ocean bathing before it can be discharged into the sea. The start of regulation is currently awaiting ratification by the IMO. However, this standard will be applied to new ships with a ballast water capacity of less than 5,000 cubic meters constructed after 2010. The standard will also be applied to large-scale ships with ballast water capacities of 5,000 cubic meters or more beginning in 2012. Worldwide, approximately 65,000 ocean-going ships will be subject to this regulation. JFE Ballast ACE is sure, ensuring completely sure treatment, simple, being a simple compact system, and safe for both the ship's crews and the world's oceans. These are the three basic concepts of JFE Ballast ACE. Now, let's see how the system achieves each of these aims. First, sure treatment. The system can be broadly divided into the filter, injector, and venturi components. Treatment of ballast water taken on by the ship begins with the filter system. The ballast water enters the filters from the bottom, and plankton with sizes of 50 microns and larger are removed by the filter element. Filter elements are automatically backwashed in sequence. The removed plankton with sizes of 50 microns and larger are returned to the sea together with the ballast water. During backwashing, the other filters continue treatment. Next, the injector injects a disinfectant at a number of points. The venturi system consists of a large number of conical venturi tubes arranged in parallel. The venturi system ensures uniform instantaneous mixing of the disinfectant. In addition, bacteria adhering to sand are separated, heightening the disinfection effect. Simple. A simple system with a compact design. The JFE Ballast ACE system is extremely compact. The unit can easily be installed in the limited space of a machine room. Because the equipment requires only about 3 kilowatts of power, it is not necessary to increase the ship's generator capacity. Because the chemical injection rate is controlled automatically by the residual chlorine meter, operation is simple and does not place an extra burden on the crew. Safe. A safe system using common chemicals. Safety is not a problem with JFE Ballast ACE. The disinfectant sodium hypochlorite is a widely used general-purpose chemical with proven safety. The residual chlorine is completely decomposed by a reducing agent and has no effect on the natural environment. Supply of the sodium hypochlorite disinfectant and sodium sulfite reducing agent to ships is possible worldwide. A wide range of JFE Ballast ACE systems is available for ships of every type, and ballast water capacity. This system is suitable for both existing and new ships, and for ships of every size. Introduction of ballast water treatment systems is an important issue for every ocean-going ship and cannot be avoided. The features of JFE Ballast ACE include sure treatment, easy installation and operation, and complete safety for the crew and the marine environment. And all these advantages can be realized at low cost. JFE is ready to support every business that's committed to protection of the global environment and a new era in maritime transportation.
Water hammer is a shock wave transmitted through fluid contained in a piping system. It occurs when fluid in motion is suddenly forced to stop moving and frequently occurs at pump shutdown. We'll be showing the difference between using a swing check valve and a spring-assisted DFT silent check valve. Here you can see the fluid flow upon pump startup. The motion and slamming of the swing check can cause damage to sealing surfaces and fatigue, and wear to the hinge pins. When the pump shuts down, it is gravity and reverse flow that closes or slams the swing check valve closed, resulting in pressure wave build and water hammer. Water hammer can also damage pipe hangers, instrumentation, and lead to dangerous work environments. Now you see an Excalibur model DFT spring-assisted silent check valve on pump startup. When the pump shuts down, the spring-assisted silent check valve closes ahead of reverse flow before fluid momentum changes direction, thereby significantly reducing water hammer. Pressure spikes are minimal because the disc closes ahead of the reverse flow. Now you see a side-by-side comparison of DFT's silent check valve and a swing check. University and independent laboratory studies have shown that the dynamic characteristic of the axial flow, spring-assisted silent check valve, DFT check valves, favors fast closing ahead of reverse flow, therefore reducing pressure spikes and water hammer.